We're going to do a problem here where we're going to find the intersection between two lines, which will result in their common point between the two lines. Let's first of all look at the problem and do a rough sketch. The first line we have is going to have the point 1, 2. Okay, so we'll go 1, 2. And it's going to have a slope of 1/2, so we could approximate a slope of 1/2. And 45-degree angle would be that one. So I think this is pretty much good for that one. We'll call that line 1. So this is my line 1. The second line will be a slope of -3/5, and the point defined will be -4, 5. So we're going to go 1, 2, 3, 4, and up 5. So that's our point. Let's kind of label these 2 points. This is going to be 1, 2, and then this will be -4, 5. And it's going to have a slope of -3/5, so it's going to go down and to the right, and I'm not sure where this is going to intersect, but let's not make it look like it's intersecting at 1, 2. Okay, let's make it just, this is our question mark. So we're going to look for this common x here, and we're going to look at for this common y. So let's first of all use point slope form to write our equation. And if we do that for the first equation, for equation 1, we'll get y is equal to 1/2 times the quantity x minus 1 plus 2. And so for our equation 2, we'll get the linear equation y is equal to -3/5 times the quantity x plus 4 plus 5. Okay, so those are two linear equations, and using substitution, we'll let the right sides equal to each other. So we'll write the algebraic equation 1/2 x minus 1 plus 2 is equal to -3/5 x plus 4 plus 5. Okay, what we're going to do as the strategy now is we're just going to distribute, and we're going to combine like terms as we go along. We're not going to look at other simple ways of doing it. That's just the strategy right now. So let's distribute the left side, and we get 1/2 x minus 1/2 plus 2 is equal to -3/5 times x plus a -3/5 times 4 plus 5. Okay, so how we go from there, a lot of different strategies, but let's just go ahead and let's combine these two terms. We know that on the left side here we'll have 1/2 x, and we could go ahead and look at this as being 3/2. In our work zone, we can remember that -1/2 plus 2, our common denominator will be 2. I don't need to do anything with this first. It's just a -1. And we would multiply 2 by 1 in the form of 2/2. So if we did that, it would be a plus 4 here. And so now we would have 3/2. So I'm going to go plus 3/2 is equal to -3/5 times x. And again, let's do this in the work zone here. We have -12/5 plus 5, and our common denominator will be 5. Again, -12 doesn't have to be changed, but remember 5 is going to be 25/5, so I'll add 25 here. So then that leaves us with 13/5. So we're going to add 13/5. Now let's put all our x terms on the left. When I decide which way to go, I like to have positive coefficients for the x. So I always look at which of these two coefficients is greater on the number line. 1/2 is greater than -3/5, so I'm going to move the x's to the left. And I'm going to factor out the x as I do this. So I'm going to write 1/2, okay, plus 3/5 times x. I've factored out the x now. And then on the right side, I'm just going to go ahead and write this 3/2 on the other side as -3/2 plus 13/5. Okay, so let's go ahead and add 1/2 plus 3/5 in the work zone. So we know that our common denominator, if we just do it 1/2, let's not skip a step. Let's do 1/2 plus 3/5, and our common denominator will be 10. 1/2 is 5/10, and 3/5 is 6/10. So that's 11/10. Okay, so I can bring that here and put 11/10 x equals, and now I'm going to go ahead and say -3/2 plus 13/5 is going to be equal to, again, a common denominator of 10. I need to multiply this one by 5/5, so I get -15 here. And I need to multiply this one by 2/2, so I'll add 26. And that'll leave me with 11/10. Interesting, 11/10. How about that? 11/10. Well, okay, so then we multiply both sides by the reciprocal of the fraction here next to the x. Okay, so we've got that. And so we multiply this side by 10/11 as well. We find that x is equal to 1. So what I'm going to do now is I'm going to substitute into either one of these two equations. I'm just going to grab the first one. I'm going to say y, when x is 1, I use function notation, is going to be 1/2, 1 minus 1 plus 2, and that easily reduces to 2 when I see that 1 minus 1 is 0. 0 times 1/2, 0 plus 2 is 0. So the intersection point is 1, 2. So I've done this algebraically. Let's check it in our graphing calculator. Okay, so I'm going to turn my graphing calculator on, and the first thing I did was I put my equations into my graphing calculator, and I'm going to check my window. I'm going to zoom standard, zoom 6, and there's my line A, or line 1, and there's line 2. So we'll hit second, calc, intersect, and our first curve is y1, our second curve is y2, and our guess, we're in the vicinity, and that's close enough, and there we see we have an intersection of 1, 2.